So good day everyone, I'm Decade Calvadores. So for today's video, I will be demonstrating on how to plot the fixed position using two stars. So in plotting a ship's position using observation of stars during twilight is first we will plot our DR position and we will plot first our Markov. And then So in plotting ship's position using observation of stars during twilight is first we will plot our DR position and we will plot first Markov. So the given position latitude is 44 degrees and 10 minutes. So here. And longitude 169 and 30 minutes east. So 30 minutes. So this is our DR position here, which is the intercept between our latitude and longitude here in the center. So the next step is we will plot our ZN of our Markov. So based on our given value, the value of our ZN is 85.2 degrees. So we will go to our compass rose, then we will plot 85.2. So 85.2 is in here. So for the information of everybody, this compass rose has the scale of 1:2. So every line has the equivalent of 2 minutes. So here 85.2. Then we will bring our kaning 85.2 na our DR. So here, this is our ZN, this line. So the next one is we will plot our INT or the intercept terminal point, which is 5.2 minutes away. So we need a compass divider, then we will measure here inside 5.2. Then after we measure 5.2, we will bring it to our DR position. Then we will line it to the ZN, or it is in line with the ZN. So 5.2 here. This is our INT or the intercept terminal point. So the next step is we will plot our first ITP. So we will plot our first ITP. So we need to be more accurate in plotting. We need two triangles. We'll drag it to the here. So the value of our latitude is 44 degrees and 9 minutes since wala siya nakabot sa 10. Then we will measure longitude. You just drag it, then measure top here. So the value of our longitude is 169 degrees and 22 minutes east. So it is the our first ITP, which is latitude 49 degrees and 9 minutes north, and longitude 169 and degrees and 22 minutes east. And in order for us to get PL mark or the position line of the Markov is we will measure 90 degrees on our ZN for both sides. So like this. So here 90 degrees. This the top 90 degrees again. 90 degrees is one. But we can also use another way And for us to be more accurate, we just add and subtract our Zn to 90 degrees. So our first one is 85.2 degrees plus 90 degrees is equivalent to 355.2 degrees. Then the second one is 85.2 minus 90 degrees. That's why we get 165.2. So we just go to our compasstors again here, 55. Then our PL2 is 175 here, and then we just bring our this one we have plot to our here. So this is now our PL mark for our markup. So our position line 1 is 355.2, then our position line number 2 is 175.2. So the next one is we will plot the star result. So we just need to follow the steps we've done on our first ITP of the markup. So first, we will plot the our Zn of our Rusalski for the result, which is 183.3 degrees. So we will go again to our compass rose. So same what we have done earlier, we will plot 183.3. Then we will just bring it to our DR position. Here, this line. So this is our Zn now for our star result. And next is we will plot our INT or the intercept terminal point again, which is 6.4 towards. So we need compass divider. Then we will measure 6.4. Here. And after we measure 6.4, we will bring it again to our DR position in line with our Zn. So here, this one, this is our INT 6.4 towards. So again, unlike earlier with the star markup, the Zn, we put the Zn here on the side. It is because it is away. However, in the star result, it stays the towards 6.4 towards. That is why we put our Zn towards the star here, this way. So the next step is we will plot our second ITP. So we will first find our for the latitude here, 44 degrees 3.5 minutes north, and for our longitude is For our longitude is 169 degrees and 29 minutes east. And same what we have done earlier on how to find our position line mark or the PL. You just here. We need to measure 90 degrees to our ZN. So here, 90 degrees. Also to the both sides. And like what I've said, we can use another way for us to be more accurate on finding our position line. So here, since the value of our ZN is 183.3 degrees, we just need to add and subtract 90 degrees to our ZN. Like this, 183.3 plus 90 degrees is equivalent to 273.3. Then 183.3 subtracted by 90 degrees is 93.3. So we will go again to our compass rose, then we will plot our position, line 1 and 2. So our 273 is in here, then our 093.3 is in here, over there. So we just need to bring it to our here, this one. And now, since we're done plotting ITP and the ZN of the two stars, we will find the intersect of these the two stars, the Markov and the Rosal. So this one is the intersection for the fixed position. And now we will find the latitude and longitude of this intersection. So latitude 44 degrees and 3.5 minutes north. Then for our longitude, we'll bring it here with their intersection. So 169 degrees 24.4 minutes east. So that's all. Thank you.